Good morning, everybody. Today we're doing a little different. I'm waiting for some bearings to come in for the A6 Intruder. It's going to be about 10 days, which is a bit of a bummer. Anyhow, so I thought, I'd put some tips and tricks on composite layup and some of the tools and the methods I use, just to help some of you guys out who may not be as experienced. So let's get on with it. If you PVA the mold first prior to the masking tape, then the masking tape will not stick to the PVA and then you'll have a problem. So it's best to do the masking first, then PVA, then any paint that you might want to use. Not masking the parting planes will also cause any paint to start to build up on the parting planes, which will be extremely difficult to get off. The last thing you want when you're laying up a mold is for the mold to be wobbling around or moving. It makes it extremely difficult to get the epoxy on nice and smooth. What is this hole for? Well, it's for removing deep cavity parts which usually get stuck and are almost impossible to get out. So coming right now is the solution. All right, we have here a deep cavity mold. This is the tail cone of the EuroFighter, and it's very deep and it's built very light to keep the weight down. So it's very thin. So trying to pull this out normally would be near impossible without ripping it. So these are the tire valves that I have. I've taken the valve out of it, of course, but so it's just the tire stem. And what I do is I set my compressor to 80 psi and then just go, put your finger there. There we go. And out it pops. So there you have a finished part, and you can see the mold is very deep and it's ridges on it, I should say. So that would cause all kinds of problems. I use a cheap separate PVA gun, otherwise it contaminates paint for some reason. I can never get it perfectly clean for paint. If your epoxy is measured by volume, such as 2:1, 3:1, etc., for small jobs, these cups work wonderful. I usually use mine at 2:1 and it works fabulous. I mark the level of my epoxy containers when I'm using them. This way I can write it down in my logbook. I can keep track of, let's say I've just laid up a rudder for the A6, need to do another one, and know exactly how much volume of resin was used and what I need to repeat the part. And another tip. This is just a regular little portable drill. And what I've used is a little bit of piano wire, usually used for push rods. I believe this is 256. If you just bend it like this, you can make a nice mixing for your epoxy or anything else you're mixing up. And it actually works. So another thing is save your, whatever, whipped cream, whatever you call it, cartons. This is butter. I just wash these out and I use them for resin. They work great when you're doing a big layup, especially doing a mold. And those work great and it saves you a bunch of money. All right, now I'm going to show you a trick with these chip brushes. You can see this is straight out of the package. I've just torn the end off it. It's got tiny little hooks as it comes out of the factory, I guess. So what that does, it can, when the cloth is wet, it can actually pick up the cloth like it's doing there. And you don't want that because it becomes a pain. So what you want to do is take the chip brush, a pair of scissors, and simply cut them like that. Nice and square across. That gets rid of those little hairs and no longer picks up. So that's a tip I've learned, and it's especially bad when you've got like 3/4 ounce cloth or real light cloth, like 2 ounce, three quarters, and so forth. So do that to your chip brushes and life will be much easier. I have been using this syringe method for years. It really works great. When I was using the cake batter bag, or whatever you call it, icing bag, I would sometimes get bubbles underneath the details, which gave me voids. And since using a syringe, I've never had this problem. It also allows me great control of weight, and really works wonderful. So if you've not tried it before, just try it. I got these off, I believe it was Amazon or maybe eBay. I bought 500 for, I think, $25 or something like that. So take a look, and you can get them in different sizes. And the one I'm using right now is a 30cc size, because I tried using, sorry, it's a 20cc size. I tried using the 10cc and I was having to reload it so much more. This one allows me to do quite a bit before I have to reload it. This video I'm showing the tail end of the Super Tucano, which has all these super fine panels, access panels in the fuselage, which have Phillips screws designed into them. And the first time I did it, the edges of these super fine panels was getting little voids of epoxy missing, and it's because the air got trapped. So what I came up with was painting it with a thin down splooge, and then applying a 3/4 ounce cloth over it, which I'll show you in a minute. And that has really been a game changer. It's really changed how the finish of the detail comes out. With the splooge applied, I'm now using clear resin and applying 3/4 ounce cloth, and I'm just basically patting it with the brush, which lays down the cloth real tight and pushes any air that might be under the splooge out. This is a game changer. It just gives you the most beautiful detail on the finished part. The next thing to do with super detail is I now leave this to cure for about 5 or 6 hours till it's all nice and stiff before applying heavier cloth, and it's a game changer, seriously. The problem I was having was applying the heavier cloth over the super detail is the cloth for some reason would I guess when you tapping it in with the brush, it was pulling air underneath into the 3/4 ounce, which was giving me voids. So delaying the heavier cloths, allowing the splooge to stiffen up, really works nice. Due to the super detail on this Tucano fuselage, I've let the splooge in the 3/4 ounce literally dry overnight. Like I said in previous video tip, we were having problems. So I just don't want to wreck it up. So what I'm going to do now is paint the entire surface with resin, just clear resin. And then I'm going to cut out some 5x8 pieces of 2 ounce cloth in this case, which is the first layer. And I'm going to overlap each piece by 1/2 inch to 3/4 of an inch. What this does, it allows you to build a fuselage really light yet very, very strong, because the overlap acts like a rib or a former, which is inside the fuselage. What I found is after a couple of days, the fuselage is so stiff yet very, very light, and it's very resilient. So basically, let's put it this way: if I was using 6-ounce cloth over the entire thing as a full sheet, then I would have a 6-foot, a 6-ounce coverage. But by overlapping every 8 inches or so, by 3/4 of an inch, then it's really a 12-ounce rib, and all you've added is a few grams of extra resin and cloth. So try this. It's absolutely amazing. Works really, really well. The biggest mistake a beginner will make is allowing the epoxy to harden overnight or a few days, whatever. That's going to make it get extremely difficult to trim. So what you want to do is time it so that the cloth is dry to the touch, almost stiff, yet has just a tiny bit of flex in it. And then you just trim your knife down the edge of the parting plane, and you'll find that it just cuts real clean, real nice, no problem. Then I've got just a basic flat, reasonably sort of semi-stiff, I guess, brush, which I'm going to use the PVA on. So the next step is I'm going to go around the periphery of everything with PVA so that when I put the mold halves together, it reduces the stick, so it's easier to separate. So now the PVA has magically appeared, and I'm going to just start spreading it around. You don't want to get it onto the fiberglass edges here if you can help it. So we'll just start by coming as close as we can without actually getting it onto the fiberglass parting plane. All right, here's a little bit of a tip. Just over here, that when I was trimming this side, I probably got a bit out of kilter, and the edge pulled away, leaving about 30 seconds of an inch gap. Now, if you don't fix that, what that's going to do is going to cause the resin to get underneath, which will create an ugly bubble in this seam. So to fix it, take a heat gun, get it all heated up. When the glass is hot, just push it in, hold it for, I don't know, 20 or 30 seconds. And epoxy usually finds its original form under heat. So right now, yeah, that's closed up. So we're good to go. Just be aware, you want those seams touching right up to the molds. You don't want any separations whatsoever. Another thing is I have this nose section. The reason this is separate is because I need to gain access through this end of the mold. So basically I can get my hand or that little brush gizmo I made inside to do the seams. If I form the whole thing with this nose section on, then there's no way in. So I would have to try and do it from the rear, which is about 4 feet deep. And there's no way I'd be able to get into these corners or anything like that. So this baby, which is the nose section, gets put on last when the joint seams have been done and the two halves are together. One little bit of advice I would give you is when you do this stuff for the first time or even the second time, whether it's laying up a mold or doing actually building a mold or laying up a part like this, choose an amount of volume of resin or an amount of fiberglass cloth or whatever, and keep like a lab book. Put all that information in, because if you build one of these things several months down the road or a few years, you'll forget what you did. And like in this case, it's 30 millimeters of resin I'm trying, and if it's enough to cover the entire molds as I do them, then I might save resin down the road. All right, we're going to snip off approximately 1/8 diameter at the end there. I'm probably doing this all wrong, but I've never done icing before, so let's see. As usual. If I run out, it's no big deal in this particular instance because I can get easy access to the joint. This is more just for reinforcement. And I can get the tape in with no problem whatsoever. Alrighty. Ouch. The splooge is done on both sides. I've put extra here, more than obviously I need to join the two halves. And the reason for that is I can get into all of this section with the, all through here with the tape from this side, but I can't get into this section. So what I'm going to do is have the splooge. I'm going to flip the mold once I got them clamped and screwed. Flip the mold until this basically touches the other side, which then creates like a bond. So let's just get rid of this. You can maybe see that the splooge is just beginning to run down the edges, and that's what we want. Okay, so we're locking up all our alignment dots. I'm going to put a couple of clamps on. Guess I'm going to have to be putting a lot of clamps on because I forgot to drill holes in this mold. All right. I'm just going to be clamping this mold because I don't want to start drilling with the splooge on there and get bits of grit down in between. So it's going to make it a little more awkward to put the tape in. So before we go ahead and start mixing up any of the goop or splooge, as I call it sometimes, what I'm doing is I'm getting the tools all ready. This is a chip brush, utility brush, whatever they call them. I've put it onto a piece of 3/8 dowel, cut it on an angle. I've hot glued it in side so it's connected. So I want it on an angle so that when the molds are closed, I can reach in and spread either resin or push down the tape. Then in this case, I'm using some actual 1 inch 6-ounce fiberglass cloth tape. This you can buy like that. Now it's done the other way, and we'll in about 5 minutes or so we should see that the goop has dropped down onto the other side, which gives you a really good joint. And like I said, this is really good for things like ailerons, rudders, small parts which you can't get in with the tape. That's how you do it. Joined. I don't know whether you can see. We're going to try it, but I was able to. Unfortunately, I don't seem to be able to focus. But anyhow, right at the tip of the tail end there, I was able to put about 4 inches of the tape in by wetting the brush, sticking the tape on, and just dropping it down there until it stuck. And then you can see that I've got a nice edge all the way up. Nicely wetted out, even though it doesn't look it because of all the splooge, but it is nicely wetted. And this is how I did it. Normally I wait until tomorrow, let's say, to join the two front and back fuselages together. But this time I'm going to try doing it all at the same time. We've done the seaming, And we've prepped everything. So we'll see. Worst case, it doesn't take and I do it tomorrow. But normally what I do is I'll take the front section out of the mold, cut out the canopy and the saddle. That gives me a great big amount of room to be able to get in there and tape the joint. So what I'm going to try and do today is do a temporary glue up so that the front and the back of the fuselage come out together, which would give me really a perfect seam, hopefully. And anyhow, I've never tried this method before, but we'll see. Now, for as long as the two halves glue together good, then it's not a problem. I can cut out the canopy tomorrow, take the tape and glue them together. So here goes. Boy, these things get heavy. All right, so gonna get a really good alignment here. Okay, we've engaged everything. Put a couple of temporary clamps on. Oops. And we'll get some screws in there. And hopefully it works. All right, there's all 6 foot of our fuselage screwed and clamped together, front and back, left and right sides, top to bottom, even the nose is on there. Now you see my orange Arbor Freight chisels have magically appeared, and these are what I like to use to separate the mold. So we're just going to go around first, around the perimeters with just a little twisty motion, and try and get some relief. Just be gentle. When it cracks like that, that's good. Well, it's either that or the mold just broke, but anyhow, we'll see. So I'm just basically easing the parts a little bit. So this is probably the easiest part to lift it from. There we go. I've removed most of the flashings, and now time to check her out. So let's go through here, take a look at it. That is meant to be that little dimple there. The rivets look good. These tabs are for putting magnets in, which just keep the the cowl from moving. All around here, this little canopy lock mechanism that usually comes out when you're trying to get the mold. I think we fixed that. So except for that void, I think we've got pretty much a perfect layup. Pity those parts came out with the goop, but you can't tape it from inside, unfortunately. So the fuse has been inspected, everything looks good, and now I need to reinforce that joint. So what I did is I put masking tape first around the entire circumference of the crack. That stops any resin that when I fix it on the inside from coming through and damaging your fuselage surface. Then those cross tapes are just to make sure everything doesn't move and everything goes good. So I've cut out the front nose section there. That's where the engine access panels come up. And I've cut out the canopy, just rough cut it. And this allows me just to get in with a cut down brush some tape and resin, and finish off all the joints that we did previously in some vids, and get the strength in them, and then this baby is done.